THHN stands for thermoplastic high heat resistant, nylon coated. THWN stands for thermoplastic high water resistant, nylon coated. MTW stands for machine tool wire, thermoplastic insulated. When wire is labeled THHN or THWN or MTW, it signifies that the wire meets the standards for all three designations. Manufacturers label wire this way to indicate its versatility across applications requiring THHN, THWN, or MTW properties. THHN wire is typically used in dry or damp locations with temperature ratings up to 90 degrees Celsius, which is equivalent to 194 degrees Fahrenheit. It is well suited for both residential and commercial wiring projects. THWN wire can be used in wet or damp locations. It also has a temperature rating up to 90 degrees Celsius or 194 degrees Fahrenheit. It demonstrates resistance to moisture and certain chemicals. MTW wire finds its use in the internal wiring of machines and appliances and is rated for temperatures up to 75 degrees Celsius, which is equal to 167 degrees Fahrenheit. One primary advantage of using wire with multiple designations is its flexibility. This type of wire can be applied in a broader spectrum of applications, diminishing the necessity to acquire multiple specialized wire types. Multi-designated wire helps ensure code compliance. It assures that the wire adheres to the requirements stipulated by various electrical codes. Finally, safety is enhanced with multi-designated wire. It guarantees reliable performance and protection against electrical hazards across diverse environments. When selecting wire for electrical applications, understanding the specific ratings and designations is crucial for ensuring safety, code compliance, and optimal performance. Remember to consult local electrical codes and regulations to guarantee adherence to safety standards in your area. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. Familiarize yourself with relevant articles and tables within the NEC to ensure proper wire selection and installation practices. For instance, NEC Table 310.15b16 provides ampacity ratings for various wire types based on their insulation temperature rating and installation conditions. Ampacity refers to the current carrying capacity of a conductor, and it's essential to choose wires with adequate ampacity to prevent overheating and potential hazards. When working with electrical systems, always prioritize safety. To energize circuits before working on them, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you're unsure about any aspect of electrical work, it's best to consult a qualified electrician. Understanding voltage drop is also vital in electrical installations. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can lead to inefficient operation of electrical equipment and potential damage. The NEC provides guidelines for minimizing voltage drop in branch circuits and feeders. Consider using larger conductors or running shorter circuit lengths to reduce voltage drop. Grounding is another crucial aspect of electrical safety. A proper grounding system provides a low impedance path for fault currents, helping to protect people and equipment from electrical shock. Grounding electrodes, such as ground rods or metal water pipes, are used to establish a connection to the earth. Ensure that grounding systems are installed in accordance with NEC requirements. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to wiring and equipment. Select overcurrent protection devices with appropriate ratings for the circuits they protect. Arc fault circuit interrupters, or RFCs, are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. RFCs are required in many residential circuits, particularly those serving bedrooms and living areas. They provide an additional layer of protection against electrical fires. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs detect ground faults, which occur when current leaks from a circuit to ground. They quickly interrupt the flow of current, preventing electrocution. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas. The electrical boxes are used to enclose and protect electrical connections. They provide a safe and organized way to terminate wires and mount electrical devices, such as switches and receptacles. Choose electrical boxes of appropriate size and material for the application. Conduits are used to protect and route electrical wiring. They provide a physical barrier against damage and environmental factors. Conduits are available in various materials, such as metal, plastic, and flexible types. Select conduits that are suitable for the installation environment and comply with NEC requirements. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include non-metallic sheathed cable, or NM cable, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. Choose wiring methods that are appropriate for the application and comply with NEC requirements. When working with electrical panels, it's essential to maintain proper clearance around the panel. The NEC specifies minimum clearance requirements to ensure safe access for maintenance and repairs. Avoid obstructing the area around the electrical panel with storage or other items. Labeling electrical circuits is crucial for identifying and troubleshooting electrical problems. Use circuit directories to document the purpose of each circuit breaker or fuse. This can save time and prevent confusion when working on electrical systems. Regularly inspect electrical systems for signs of damage or deterioration. Look for frayed wires, cracked insulation, loose connections, and corroded components. Address any issues promptly to prevent potential hazards. Proper maintenance is essential for ensuring the long-term reliability and safety of electrical systems. Consider scheduling periodic inspections and maintenance by a qualified electrician. They can identify potential problems and perform necessary repairs or upgrades. When making electrical connections, use appropriate connectors and terminals. Ensure that connections are tight and secure to prevent overheating and arcing. Avoid using wire nuts or other makeshift connectors, as they can be unreliable and unsafe. When running wires through walls or ceilings, use proper support and protection. Secure wires with staples or cable ties to prevent them from sagging or becoming damaged. Avoid running wires through areas where they could be exposed to physical damage. When working with high voltage systems, exercise extreme caution. High voltage can be lethal, and it's essential to follow all safety precautions. De-energize circuits before working on them and use appropriate personal protective equipment. If you are not qualified to work on high voltage systems, it's best to consult a qualified electrician. Electrical safety is everyone's responsibility. By following safe practices and adhering to electrical codes, you can help prevent electrical accidents and ensure the safety of yourself and others. Remember, when in doubt, consult a qualified electrician. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it's essential to have the necessary knowledge and skills before attempting any electrical tasks. Consider enrolling in electrical training courses to learn more about electrical safety and best practices. These courses can provide you with the knowledge and skills you need to work safely and effectively with electrical systems. Stay informed about changes to electrical codes and regulations. The NEC is updated every 3 years, and it's essential to stay current with the latest requirements. Attend industry events and subscribe to trade publications to stay informed about changes in the electrical industry. Promote electrical safety in your community. Share your knowledge and experiences with others and encourage them to follow safe practices. Together, we can create a safer environment for everyone. Always remember to prioritize safety when working with electricity. Your life and the lives of others depend on it.